To find each trigonometric value here, you need to understand how to use the unit circle and the respective right triangles whenever you're dealing with degree measures. So in the first case, there's definitely a degree measure of 120. We need to find sine of 120, the value of that. So to start, you need to understand how to use the reference angle when it comes to 120 degrees. 120 degrees lies in quadrant 2, because we know in the xy plane, in the unit circle precisely drawn in the xy plane, when you start from the 0 position for the angle, you always travel counterclockwise, right? So you travel 180 degrees, making a straight angle here, right, at this point. But 120 degrees is smaller than that, but it's still in quadrant 2 because quadrant 1 maximum ends at 90 degrees, right? So 120 definitely lies here. So that means the green side here that you see is the reference angle situation applicable to this question, right? So that means the terminal side is the side for the 120 degree measure. And to find the reference angle, you just need to subtract this 120 degrees from the straight angle of 180, and then you will get that terminal side measure, positive measure, right? So let's see, that's going to give us 180 minus 120. So you happen to have sine of 60 degrees. Now here's where these two right triangles become handy. As you can see, when it comes to 30, 60, 90 triangles, we have a side ratio of 1, radical 3, and 2. Right, so we're definitely going to use this triangle and not that one because these angle measures are not the ones that we need. So sine of 60 is the opposite, which is radical 3, divided by the hypotenuse, the longest side, which is the opposite side to the 90 degree angle. That's always a hypotenuse. So radical 3 over 2. Now here's where we have to be careful. Sine of 60 is positive, but what about sine of 120? As we know, the sine is basically, for any point on the circle, the sine is always going to be the y value, right? The vertical distance you travel. Now the sine is the y value. In both first and second quadrants, the sine is positive, right? So the 120 degree measure we said was in quadrant 2, the sine is positive. And in the first quadrant, where the 60 degree angle is that we found, the reference angle that we found, is also positive for the sine, right? Sine is positive in quadrant 1 because 60 degrees now lies in quadrant 1. So since the signs match, we don't need to negate anything. We don't need to place a negative before the sine of 60, right? So it's going to be straight out like that. So sine of 60 is going to be opposite divided by the hypotenuse, radical 3 over 2. Good. The second question, cosine of 5 pi over 6. This time it's going to be radians, right? Not going to be degrees, but radians for the angle measure in question. We know that 6 pi over 6, for example, is exactly pi, right? So 180, just like 180 degrees in the previous question, pi corresponds to the radian measure of 180 degrees, right? The corresponding measure in radians is pi. That matches 180 degrees. So we know 6 pi over 6 is equal to pi. So 5 pi over 6 is just a little smaller than that. It's smaller than 6 pi over 6 by pi over 6, right? You subtract pi over 6, you get 5 pi over 6. So that means it's definitely going to be way bigger than the pi over 2, right? Pi over 2 is going to be 3 pi over 6, right? So 5 pi over 6 again is in quadrant 2. So again, we can apply the same situation using the green reference angle here. So that means we are subtracting 5 pi over 6 from pi radians, right? Just like we subtracted from 180 degrees, right? So it's going to be pi minus 5 pi over 6. Now, before we go any further, let's think about if there are any sign changes involved. So realize that for the cosine, any point on the circle that you place, the cosine will be the x value for that point, right? Because there's an x value and the y value pertaining to any point in question on the circle, right? These points have coordinates to them. Like this one has 1, 0 because this is a unit circle of radius 1. This one has 0, comma 1. This one has negative 1, comma 0. And this point has 0, comma negative 1. Right? So every point has a coordinates, two coordinates, x and y, associated with them. So in this case, what we need to understand is that the cosine in quadrant 2 is negative, right? Because when you travel when you have an x coordinate from the origin in quadrant 2, x coordinates are going to be negative, right? So we're definitely here, so that means the x coordinate is going to be negative, right? So the cosine of pi over 6 is negative. But look what happens when we subtract 5 pi over 6 from pi. We get basically 6 pi over 6 minus 5 pi over 6, which is pi over 6. Now pi over 6 lies in quadrant 1. Now in quadrant 1, pi over 6 makes it possible that the cosine is positive. But the original angle measure, even though we found the reference angle of pi over 6, the original angle of 5 pi over 6 made the cosine negative. So to compensate for that, we should negate the reference angle, the cosine of the reference angle. Otherwise, it would not be the right answer, right? So we negate it, and it's going to be minus. Now, what is cosine of pi over 6? That you should remember, right? It's radical 3 over 2. So the answer to this is minus radical 3 over 2, or negative radical 3 over 2. Okay, next question. Now you realize up until now we only had positive angle measures, right? And that's what we always should go to, right? The angle measures that we should have should be from 0 up until 360 degrees, or from 0 up until 2 pi radians, right? This is the range that we should have for our angle measures. In this case, the angle measure is negative, so we should make it positive. Now, how do we make this positive? How do we make it positive in such a way that the position of the terminal side will be the same, right? So that we wind up at the same point on the circle. How do we do that? We use this fact. Notice that when we start counting the angle measures, we start from the theta angle measure of 0, degrees or radians, doesn't matter. And then when we go all the way until 300, all the way until the end of the circle, all the way around, we get to 360 degrees in degrees, right? Or 2 pi in radians, right? So this counts for the entire circle, right? We go through the entire circle this way. So that means if we simply add 360 degrees, we will get to the right angle measure, right? So to do that, look what happens. We get tangent of 315 degrees, okay? Now tangent of 315 degrees, let's see where this angle measure is gonna lie. This angle measure will be in quadrant 4, right? Because we know this is 3 pi over 2, corresponding to 270 degrees. So we definitely know that the terminal side of this 315 degrees will be applicable to the blue one. To get this respective reference angle, we have to subtract 315 from 360 degrees, right? So you travel all the way until all the way around the circle, except that you stop there, right? Short of one reference angle, right? To find that reference angle, just subtract 315 from 360, right? So 360 minus 315, right? Notice that all your reference angles are going to be in the first quadrant, right? All of your reference angles are going to be in the first quadrant, okay? That's the nature of doing it right. So now, as a result, you have to always be careful, because look, in quadrant 4, the tangent is going to be negative. Why is that? Because tangent is the sine being divided by the cosine. All right, so tangent, the quotient of the positive and negative, will be negative, but the tangent is positive in quadrant 1, right? So that means the original angle measure of negative 45 degrees was also here in quadrant 4. We made it possible because we found the reference angle in quadrant 1, but the tangent was originally negative and now it's positive. So that means we have to negate once again. And where does the negation start to take place? Not here, right? Because we didn't change the position yet. We changed the position as soon as we found the reference angle, right? So that's going to be here, right? That's where we change the position, right? So that means we have to negate here. So negative of tangent of 45 degrees. Now tangent of 45 degrees, so negative of what? Now let's use this triangle this time because we have a 45, 45, 90 triangle. Tangent of 45, we can use any of these angles, and as you can see, the opposite side to each of them is 1, right? So it's going to work with any of these. Opposite over adjacent accounts for the tangent. So opposite over the adjacent, or you can say the same thing with this one, opposite over the adjacent. So 1 over 1. Negative 1 over 1 is negative 1. So the answer is negative 1. Now 7 pi over 6 for the cotangent. Cotangent of 7 pi over 6. How do we find that? You realize, first of all, that 7 pi over 6 is going to be in quadrant 4. Or is it not going to be in quadrant 4? Let's see. 6, well actually no, I'm wrong. 6 pi over 6 is going to be pi. 7 pi over 6 is going to be in quadrant 3. Right? Because 9 pi over 6 exactly is going to be 3 pi over 2 if you reduce it. Right? So 7 pi over 6 is definitely going to be in quadrant 3. Okay, do this algebra on your own, you'll see what I'm talking about. So 7 pi over 6 is just the pi over 6 above the 6 pi over 6, right? So it has to be here. So that means it's the orange reference angle that we're trying to find. To find this reference angle, guess what happens? We just have to subtract pi from 7 pi over 6, and then we will get that extra reference angle that is being formed, right? So imagine that you travel pi radians, or 6 pi over 6 radians, and you need to travel pi over 6 radians more to get to this terminal side to give you 7 pi over 6. So that means you don't need 6 pi over 6, or you don't need the pi, right? So you just subtract it, right? So cotangent of 7 pi divided by 6 minus pi. Right, now let's think of the signs. Before we do the algebra, let's think of the signs. So in quadrant 3, by the way, cotangent carries the same sign patterns as the tangent, right? Because the cotangent is the reciprocal of the tangent. Now, tangent in quadrant 3 is positive because the cosine, which stands for the x value of the point in question on the circle, is negative, and also the sine, which accounts for the x value of the point on the circle, is also negative. So thus the tangent, the quotient of the sine and cosine, is also positive. So that means the cotangent is also going to be positive because cotangent is the reciprocal of the tangent. Right? So that means it's going to be positive here. So if we make it positive such that the reference angle is in quadrant 1, we'll still have the same sign. So we do not need to make a negative sign or change the sign. All right? So we can just do algebra. So cotangent of pi over 6. Now cotangent of pi over 6. So let's see. We know that the tangent of pi over 6, and if you forget this, always just remember that this is equal to cosine of pi over 6 over sine of pi over 6. Right? That will be simple to remember it that way. Okay? Because when cotangent is the reciprocal of tangent, you know that you just have to reciprocate the sine and cosine, right? Just in case if you forget, because the tangent is sine over cosine. So thus the cotangent, since it's a reciprocal of tangent, is going to be the flipped fraction, which is cosine over sine. Right? Cosine of pi over 6 is what? We already had that here, right? It's radical 3 over 2. Now sine of pi over 6 is 1/2. We know that well. Since we're dividing by 1/2, we can multiply by the reciprocal instead of dividing by the 1/2, right? We can do that algebraically. That's the rule of algebra. So that means the 2's cancel out and we get radical 3. Right? So the answer to this is radical 3. Now the next question is secant of 240 degrees. Where does this 240 lie? The 240 lies in quadrant 3, right? Because 270 is the end of quadrant 3, 180 is the end of quadrant 2, so it has to be between them, which is quadrant 3. So that means it's the same orange situation for the reference angle that we're using, same as the question before it, except we're in degrees. Now let's understand. So I'm going to have some space just to see if we're going to need the sign change, right? But first let's do the algebra. So we're subtracting 180 degrees from 240, right? Like in this case, except we're in degrees, right? So we're going to have what? We're going to have secant of 60 degrees. Okay, secant of 60 degrees. Let's see if we need the sign changes. Secant carries the same signs as the cosine. The cosine in quadrant 3 is negative. The secant will be positive in quadrant 1, right? So that means we need to account for that sign change. So that means we have to negate that to keep the secant negative as it should have been in the beginning, right? So it's going to be negative. Now let's see what it's going to be. Definitely a minus. Now what is that going to be? Secant of 60. Secant of 60 is, let's see, so the cosine is adjacent divided by hypotenuse, right? 60 is here, the adjacent side is 1. So 1/2. 1/2. So that means the secant is the reciprocal of that, right? Hypotenuse over adjacent. So 2 over 1. So that gives us -2. So that's the value of the secant of 240. Now the last question, 2 pi over 3. How do we find that? How do we find 2 pi over 3? So let's see, 2 pi over 3 is a pi over 3 less than 3 pi over 3, right? So 3 pi over 3 is exactly pi, right? It counts for complete 1 and 2 quadrants here, right? This is the point for the pi. So you travel half a circle. So 2 pi over 3 is pi over 3 less than that, right? So that means it's in quadrant 2. So that means we need the green reference angle situation here. We're going to use that. So that means we have to do what? We have to subtract this from pi, right? To give us this reference angle, right? So let's leave some space to see if we're going to need any sign changes. So we're going to subtract this angle from pi, right? So that means we're doing 3 pi over 3 minus 2 pi over 3 essentially, right? So that gives us, and I'm leaving space just in case if we need sign changes, right? So we're getting to pi over 3, right? So that's the reference angle we found. So let's see now, the cosecant in quadrant 2 has this, cosecant in general has the same sign patterns as the sine does, right? So cosecant and sine have the same signs, right? Same sign patterns in all quadrants, right? So in quadrant 2, the sine is going to be positive, right? Because the sine for any point on the circle, sine accounts for the y-coordinate, right? The y-coordinate. The y-coordinate is going to be positive for the sine here in quadrant 2, and so it is going to be positive for cosecant. So thus changing it to quadrant 1, because we are now at the reference angle pi over 3, does not change the sign. So that means we do not need to place the negative anywhere there, right? So we can just find the cosecant of pi over 3 right there, clean. Now, cosecant of pi over 3 is going to be 1 over sine of pi over 3, right? 1 over sine of pi over 3, right? Because cosecant is the reciprocal of the sine, right? So 1 over, now what is sine of pi over 3? Sine of pi over 3 is going to be radical 3 over 2. So that means the 2 goes up and multiplies the 1. So the answer to this is 2 over radical 3. Thank you so much, and I'll see you in the next video.